In this video, we're going to show how you can dramatically increase productivity at your shop with regard to programming standard parts, both 2D and 3D. Also going to show you the power of Roney Software for Manufacturing's Rapid Programming module. So let's start by bringing in a cavity directly from SolidWorks. This involves no translation. In fact, it could have been launched from SolidWorks. It's fully associative. And EdgeCam is associative with all the major CAD systems in a similar manner. Let's open up our RPM module. We're going to identify this as a cavity. We're going to want to apply 3D finishing toolpaths after the roughing is done. We want to automatically number our tools, generate the code file, and select what zero we might want to use. Now we're going to start our timer and press OK. Rapid Programming module automatically identifies the part, puts it in a proper fixture based on your company's preferences, in this case an automatic vise, puts stock around the part, identifies the 3D pocket feature, identifies which machine should be used in programming this 3D part, and immediately starts to apply toolpath. And as we can see, we're rough out the part already. Now we're starting to rest rough, that is, pick out the corners and the smaller areas the first tool missed, and rest rough again. And now the module has suggested a parallel lace finishing cycle, starting with a 3/8 ball mill. And there's a number of different options that could be changed with just a click, but the idea is to use the preferences that your company normally would use in machining this part. So now we start to apply finishing toolpaths. In this case, a parallel lace cycle that will automatically parallel lace in the X direction, then come back and identify which areas in the Y direction should be machined parallel lace to give you the best possible finish for your part. Now it's suggesting a rest finishing cycle, starting with a 3/16 and ending with a 16th. And again, we could change that to whatever our preference is, but in most cases, our company finishes with a 16th ball mill. Now that will take a little bit of calculation time, so what we're going to do to be as efficient as possible is open up another session of EdgeCam, start the RPM macro, and do a prismatic part. And again, we're going to want to do all the things that we did on the first one, so we just press OK. And in this case, we set it on some parallels. We identify all the 2D features, put it on a Haas machine in this case for our 2D machining, because that's our preference for our company. We're roughing out the pockets, rest roughing the pockets, identifying all the holes that need to be machined, whether it be reamed, tapped, or bored, based on our company's preferences. And same thing with the large holes. Do they want to be drilled and circular interpolated, helical milled out, whatever the company preference is that we've captured for our company. And of course in the background we're still finishing up our 3D part. With 64-bit machines we can have multiple sessions open and be as efficient as we possibly can. So we're coming up on 3 minutes and we've got the part completely programmed with all the instructions there. Now we're going to rationalize it, that is, minimize the tool changes, give us the most efficient tool path possible, and we're going to automatically go in and number the tools based on the order of operation. Now if we already have the tools numbered, then that step would be ignored. And we have full control over that as well. So there we go. We've got this part programmed. Let's see what we've accomplished. Go into our simulate machining. And for the sake of time, we'll run through this fairly quickly. But as we can see, EdgeCam has full machine simulation, so you can realistically see what's going to happen out on the floor. And let's just zoom that out, rotate that around a little bit, and let it run fairly quickly just so we can see that this part is totally machined. Let's go back. Maybe we want to do a second part, so let's open up another part, and we'll do a packing adapter. We don't need to save the changes for that particular part for this demonstration. Normally we would. Hit the RPM. Again, it's a prismatic part. Well, we can see visually looking at this, we want a profile around the outside, so we'll check that as well. Other than that, we can just press OK. And again, EdgeCam identifies what kind of fixturing our company would use for this particular part, which machine it would put it on, and immediately goes out to machine the part. So we're on our third part here, coming up on 5 minutes. And incidentally, even in the 2D options, we could uncheck the checkbox to automatically do everything, and we could have full control over how this part was machined. But again, the idea is that it's already set to what you would normally do on a part of this nature. So there we go. We've got that one programmed. Simulate that very quickly. And as you'll see, we automatically avoided machining the fixturing. Again, for the sake of time, we're running this fairly quickly. We decided with our company that we would helical down the outside of that part. And there we go, we've got that part complete. Okay, so let's close this session of EdgeCam and go back, take a look. And sure enough, we'll stop our timer. Our 3D part has been machined. And in this case, we'll do the rapid result. Now let's see what we've accomplished. Here's our roughing, our finishing with a 3/8 ball, then coming back with a 3/16 ball, all the way down to a 1/16 ball. And let's do our view comparison. And we can see that everything is green except for some areas in here that we might want to come back with another rest finishing cycle or burn those areas. But in any case, we're done. Stop our timer. And that completes this demonstration. For more information, contact Roney Software for Manufacturing.com, RONEY software.com, or you can call us at area code 814-217-0710. Thank you.